All right, we're going to go ahead and start the Chapter 2 review. It's in your books on page 107. We'll go ahead and get started here. So basically, 1 through 4 is inverse-converse stuff. I'll do 2. It's kind of more of a math thing. We need to turn it into if-then statement first. So basically, it's going to be if. I'll make it capital. 4x plus 9 equals 21. Then x equals 3. Converse. Converse, we switch the order. So if, and you need to memorize what these words mean, the vocabulary, so you know how to do it. Then 4x plus 9 equals 21. Okay, inverse. If 4x plus 9 does not, that's how you do the does not equal 21, then x does not equal 3. All right, and the contrapositive, if x does not equal 3, then 4x plus 9 does not equal 21. All right. And biconditional statement, it's not a big emphasis, but we can do that. Basically, this is how it works. 4x plus 9 equals 21 if and only if x equals 3. Biconditional statement, I don't think we went over it great in class. Basically means you can write this in any order you want to, and it will be true. So I could write it forwards or backwards. Okay, and basically if all 4 of these things are true, then your biconditional will be true. All right, that's that. And so we're going to move on to 7 and 8. And I'm going to kind of just do all of this and try to explain it a little bit one last time. So 7, use the law of detachment to make a valid conclusion. If an angle is a right angle, then the angle measurement is 90 degrees. Okay? If the first part is true, then the second part is true. So the first part is true in this case because it says angle B is a right angle. Therefore, angle B measures 90 degrees. And that's all that is. Use the law of syllogism to make a true statement. It says if x is 3. And so basically you got your P, your Q, and your R. So if x is 3, so that's going to be your P. Then 2x equals 6. I remember what I don't like about this. This one won't be on there. This one I don't like how it's set up. It's not true to the law of syllogism. This book likes it like this, but I don't, because that's not how I'm going to put it on the test. So either way you do that, but just remember it's got to be the first statement. Then it has to be the second statement, third statement, and then P, then R. Okay. Now we're getting to the stuff that really matters, and I'm trying to remember what I assigned. Because we're at the algebraic reasoning, so we need to solve and justify each step. I think what I did, and regardless, we can still do it. I think what I did is 19, and let me go ahead and get my new page here. Okay, and this is going to be important for the test, that you need to go ahead and draw a table. Let's make it nice, big enough. So it's 2 columns, so make sure you have your 2 columns. Oops, probably won't need that much. All right, and so we're just going to start out, and regardless of what I assign, 19 should be a good one. To do a full problem here, I don't know, maybe it'd be better for me to do, maybe it'd be better for me to do 7. I think it'd be better for me to do 17 so we can see that. Okay, so I'm going to go ahead and write this down here. So that's 15x plus 22 equals 7x plus 62. Now, in the textbook, they don't quite do it how I'm going to do it on the test. In the textbook, let's see here. Well, they're going to make me look someplace else. In the textbook, they're going to give what we're supposed to prove. On the test, we're supposed to give what we're supposed to prove here. And so I will give that to you right here, real quick. All right, we should be recording again. We're supposed to prove that x equals 5. All right, and there's multiple ways to do this, but the first thing should always be this. If you are not writing this on the table and writing a given, you're going to get points off, so don't do that. That's easy. Okay, now we're going to just look at this, and there's multiple ways to do this. Most people would probably subtract 7x and do that, but I just want to show you kind of another way you could do it. We're going to subtract 15x minus 15x. The reason why we're allowed to do that is going to be the subtraction property, okay, of equality. And I'm doing an algebra here, and so that's no bueno. We don't have to show that. So let me actually do the geometry way we're supposed to do this here. And so we're going to get that done again. I just made an algebra video, so I forget we're supposed to do it slightly a little different. 5x plus 22. Prove x equals 5. All right, and again, I could do this. I'm going to use a subtraction property. And I'm going to end up with 22 equals negative 8x plus 62. Of course, you could have subtracted 7 from both sides and had the x on the other side, but I want to show you what happens when this happens, just to make sure that you have all that you need to know. I'm going to use the subtraction property again, and I'm going to get a negative 40 over here. And let's see here, that is the subtraction property again. And then probably I'm going to do the division problem, division property, and I'm going to get, I'm using abbreviations, and it would be nice if it's straight, I'm sure. There we go. And remember, if we switch this order at the end, this is why I want to do this, that's the symmetric property. Okay, symmetric property of equality, and that proves it, that x equals 5, that is our goal there. And you need to have all these properties in your notes, and when we take the test, you're going to get to use your notes. And if you have forgotten where it is, or you don't have them in your notes because you are sick, you probably need to get those down. Those are in chapter 2, and we did those in section 3, chapter 2, and that is on page, let me pause it and I'll get you the page. I'm trying to pop. It is not behaving, so I'll just find the page. It's not in chapter, it is in page 84. That's not 8.4, that's 84. 84, 85, and 86. You're going to need all of those properties, page 84, 85, and 86, to help you out, and that is actually in section 2.4 in your book. And that's basically it from chapter 2. If you got that stuff, great. So hopefully you're good to go, and I'm going to close this one off. That's my arm. Bye.